3D bioprinting of living tissues. Degenerative diseases resulting from chronic tissue and organ failure are very common. For the cure, organ transplantation is required. Renal failure, damage to heart tissue, deficiency of the corneas. As a solution to this problem, since 1993 organ transplantation is practiced. The organ bank is represented by the cadavers. New solutions are made to meet the demand for organs, which are tissue and organ synthesis by means of cell culture and 3D printing on tissues and organs. 3D printing is one of the most innovative technologies in recent years. Its applications in medicine range from the development of models to recreate diseases to the generation of organs in the laboratory. The most recent research tries to go a step further, using 3D printers to manufacture human tissues with which to replace, perhaps in the not-so-distant future, the artificial prostheses that are used today.
Multidisciplinary research at the Wyss Institute has led to the development of a multi-material 3D bioprinting method that generates vascularized tissues composed of living human cells that are nearly tenfold thicker than previously engineered tissues and then can sustain their architectural function for upwards of 6 weeks. The method uses a customizable printed silicone mold to house and plumb the printed tissues on a chip. Inside this mold, a grid of larger vascular channels containing living endothelial cells in silicone ink is printed, into which a self-supporting ink containing living mesenchymal stem cells is layered in a separate print job. After printing, a liquid composed of fibroblasts and extracellular matrix is used to fill open regions within the construct, adding a connective tissue component that cross-link and further stabilize the entire structure. The resulting soft tissue structure can be immediately perfused with nutrients as well as growth and differentiation factors via single inlet and outlet on opposite ends of the chip that connect to the vascular channel to ensure survival and maturation of the cells. In a proof of principle study, 1 cm thick bioprinted tissues construct containing human bone marrow, living mesenchymal stem cells, surrendered to be connected tissues and supported via an artificial endothelial light vasculature, allow the circulation of bone growth factors and subsequently the induction of bone development. This innovative bioprinting approach can be modified to create various vascularized 3D tissues for regenerative medicine and drug testing endeavors. The Wyss team is also investigating the use of 3D bioprinting to fabricate new versions of the Institute organs on chip devices, which makes their manufacturing process more automated and enables development of increasingly complex microphysiological devices.